let C be defined by C of x, x minus 1, if x is less than 0, or x squared plus 1 if x is greater than 0. Now the question is f differentiable at x equals 0? Is it continuous at x equals 0? Now let's figure this out. Now what we have to do for this problem is figure out the limits. And if you know the limits of f of x prime equals the limit as h approaches 0 equals f x plus h minus f of x over h. And sure, we have g, but we can just change this letter and call it a g, and this one a g as well. And basically what this means is that we can create a chart of this stuff. So let's get started. Let's look at the left side. So less than or equal to 0, and this is g of x equals x minus 1, and the limit as h approaches 0 from the left is basically x minus h minus 1 minus x minus 1 over h. And if we do a little bit of algebra, we figure out that this is negative h minus 1 minus 1 over h. And this is actually positive 1, sorry. And positive 1, and this is the limit as h approaches 0. And you can immediately tell that these cancel out, and it'll be negative h over h, which equals negative 1. Now, what do we do for the next one? Keep in mind, we're going to remember that negative 1. And now, for the next problem, we're going to look at everything greater than 0, which is the equation g of x equals x squared plus 1. And this is the limit as h approaches 0 from the right side of x squared plus h plus 1 minus x squared plus 1. Now if we do a little bit of algebra, the 1's cancel out, and the x squares cancel out. Oh, and this is all over h, sorry. So what we're left with is h over h, which equals 1. Now if we know negative 1 isn't equal to positive 1, so we can tell from this is that in the first problem, is it differentiable at x equals 0? Now I like doing it like this, differentiable. When I see this, I just do it like that. But you might have the word differentiable, but I don't know. Now it's not. So I will say is not differentiable at x equals 0. So in the second part, it is not continuous at x equals 0. And that's our solution for that one. I hope this helped.